I'm Anil Kumar, and here is an important distinction between combination and composition of functions, which we are going to understand. Now, many of my students have doubts on this, and therefore I thought, let me make a video for all of them, and it should help many other viewers. So, to explain the concept between or the difference or similarities between combination and composition of functions, let's begin by taking some simple functions. Let's say f of x is square root of x, and let us say g of x is a straight line, and let me take this as, let us say, x minus 5. Okay, so we have two functions, and we will consider their combination and composition. So when I say combination, then really it means I could do sum, difference, product, or quotient of these functions. That is what combination is, right? So when I say combination, then I mean I will be doing f plus g, or we could do f minus g, or we could do f dot g, or we could do f divided by g, right? So these are the combinations, right? If I say composition, then we are trying to say something like f of g, right? Or we are saying g of f. So that is the composition of the functions, right? So that is one thing which you should understand. And remember one thing, that combination can only be done on common domain. So combination can be done on common domain. And when we do composition, then they have some restrictions on domain, right? It is not necessary to do it on common domain, but there will be some restrictions, and we will soon see how to find those restrictions, right? So definitely this is not kind of common domain of original function. That is what, when I say common domain of f and g, that is what I mean, right? So here we'll have restrictions, and you'll also notice that sometimes the restrictions may not be linked with one of the functions. It will be definitely linked with one of the functions, but may not be linked with the other. So this is what we are going to consider. So to begin with, there are so many options. So in this particular video, let me take f plus g here, right? We'll take f plus g, and on this side, we'll consider f of g. When I write f of g, I mean, some of you write like this, g of x, right? So that is the way we will do composition of functions. So this function is f is composed of g. That is what it is. Now here it is combination of these two functions. Now, okay, what we should do is, let me sketch this kind of function also. So the two functions could be sketched as square root function is, like this, right? So that is the square root function. And the line is at minus 5 will have 5. So line, I'm not sure where, I'm not drawing any x's here. Let me use a different ink, okay? So a line will be kind of like this, okay? So I'm just drawing at random. I hope you understand the concept. And here, this point will be, for sure, 5, right? Minus 5. Okay. Since this line has a slope of 1, so this is 5 and this is also 5, and somehow it is just kind of like this. Okay. Now when we say combination of f and g, then it really means what? It means that we can combine these two, add them up, simple addition, correct? So we'll write f plus g will be equals to function f is square root of x. We'll say square root of x plus g of x is x minus 5. That is what it means. Okay, so that means wherever the domain is common, we superimpose one on the other, right? So basically, you superimpose functions, right, and get your result. So for the same value of x, you combine them, right, and then you get your result. So if I have to draw f plus g, it really means that at 0, the value of one function is 0, the other one is minus 5. When you add them up, you get a value here. At this point, the value of one function is 0, the other one is something. So when you add, you get something there, right? In between, it is kind of this much less, so it'll be kind of here. So you can actually combine these values kind of like this and add them up, right? So it'll be kind of like this. Do you understand? So this, your function shown here, will be f plus g, right? And you can clearly see that the domain of the function, which I'm talking about, f plus g, okay? So domain of f plus g is the common domain of the two, right? So here there are no restrictions. The domain here is that x belongs to real numbers, and the domain here is that x is greater than or equal to 0, correct? So the common domain is x belongs to real numbers where x is greater than or equal to 0. So that is what we're trying to say when we talk about combination of functions, right? Well, you could do subtraction, multiplication, division, but the concept remains same. Okay, now let's talk about the composition of functions. You have understood that part, right? So it's kind of a linear combination in this case. So each value of x, you have to add the y values, right? So corresponding y values to get the result, right? So that is how it is. Now, when we say composition of functions, then it really means if I say f of gx, that means f of g of x is x minus 5. So we get this as x minus 5 here. Do you see that? So we just substitute the whole function x minus 5 within f, right? Now, it becomes equal to f function square root of x. So within square root, I have to write this x minus 5. So basically what we did was we substituted one of the functions as independent variable in the other function and got a new function, square root of x minus 5. Do you see that part? Now in this particular case, as you can clearly see, the composed function is the square root function translated 5 units to the right. So it's kind of like this. Do you see that? As you can see now here, what is the domain of this function? So the domain of the function f of g is equal to x belongs to real numbers, but x is greater than or equal to 5. So it is not 0, do you see that? So it is shifted. So it's a different function, and that is how it is, right? So that is how we do it, correct? So that is one way of looking into it, and let me show you the other possibility also, which is g of f, right? G of f means what? So that means g of, let me use a different thing this time, g of f of x, right? So that is how we'll compose the second function, and which I can write as g of, what is f of x? F of x is square root x. We'll write square root x inside. Do you see that? And that means in the function g of x, x will be replaced by square root x. So we get this equal to square root of x minus 5. Do you see that? So g of f is square root of x minus 5, right? Now in this particular case, what happens? If I want to sketch this function, I will sketch this function as square root function moved 5 units down, right? So it's kind of like this. It's moved 5 units down, and that is how the function will look like. Do you see that part, right? So in this case, it is translated 5 units down, correct? Now, here in this case, the domain of the function is, let me write, so domain of the function in this case is x belongs to real numbers where, and let me write like this, x is greater than or equal to 0. It may remain sometimes similar to that, but the operation is done not on kind of common domains, right? So that is not the criteria when we are doing function of a function. Criteria mainly in this particular case is, let me get back to that now, we are not talking about three operations, right? First is that we have this domain of x. Now, this is x. So this is the first operation. Let's consider f of g. So what happens here is that that is g, right? So domain here is domain of g, and that is the range of g. So this is, let me push this page a bit here. So this is, let me write here, range of g, right? And domain of g, this is domain of g, correct? Let me write small. Perfect. Now, when you do f of g, then the range of g becomes the domain of f. So that is f of g, correct? So what you will notice here is that this is kind of restricted. It could be more. F may have a bigger domain, right? Since in this case you saw domain was greater than equal to 0. But the domain which f can utilize from this combination becomes different. You see, it becomes this combination. The common range and domain. That is the kind of difference which gets into the picture, right? So out of the whole domain of G, it is only a portion which is valid for f of G. You get the point. So all the restrictions which apply to G will apply to f of G, plus when we have a combination, there will be some more added to it, depending on whether the range of G fits, how well range of G fits with domain of f, right? So that is how you should treat this as. I hope that makes it a bit clear to you, right? So that is how these two terms, combination and composition of functions, are very distinct. I hope that helps. Thank you and all the best.